The online auction listing was remarkably vague, featuring only a single grainy photograph of a large wooden box sitting on a pallet in a dimly lit warehouse. The description offered no dimensions, no weight, and absolutely no hint as to the contents, simply reading Lot 404, Naval Surplus Container, Sealed. Contents: machinery/industrial. Condition: unknown. For most buyers, this was a red flag to be avoided at all costs, a guarantee of buying 2 tons of rusted scrap iron that would cost more to transport than it was worth. But for Caleb and Seth, brothers who had built their entire restoration business on the thrill of the gamble, it was an irresistible siren song. They specialized in the obscure and the forgotten, turning rust into gold, and something about the sheer size of the crate and the specific stenciling on the side, faint military markings dating back to the mid-1940s, suggested this wasn't just a generator or a pile of spare pumps. They placed a bid of $5,000, holding their breath as the timer ticked down. When the gavel icon flashed on the screen, they owned 2 tons of mystery. The logistics of retrieving the prize were a nightmare in themselves. The crate was located at a holding facility 3 states away, requiring a heavy-duty flatbed trailer and a rented forklift just to get it out of the government warehouse. When they finally arrived back at their shop, a converted airplane hangar filled with tools and projects in various states of undress, the sun was already setting. The crate sat on the trailer, imposing and silent, a monolith of weathered pine and rusted iron banding. It smelled of old warehouse dust and that distinct, heavy scent of creosote. They used the shop's overhead gantry crane to lift the box, the chain straining under the immense weight, and lowered it gently onto the concrete floor in the center of the main bay. The brothers stood back, wiping grease from their hands, staring at the wooden box that now dominated the room. It was 8 feet long and nearly 5 feet high. Whatever was inside was massive. "Hey guys! We are going to crack this massive crate open in just a second, but we need to take a quick moment to ask for your help. We are incredibly close to hitting our goal of 10,000 subscribers, and we want you to be part of the crew when we cross that finish line. If you love mechanical mysteries and heavy restorations, please smash that subscribe button right now. It helps us keep buying these crazy auction lots. Also, if you want to support the channel directly so we can buy the fuel this beast is going to need, check out the Super Thanks button below. It makes a huge difference. And drop a comment. Where are you watching from today? We love seeing our global community. Now, let's get the crowbars and see what we actually bought. Caleb grabbed the largest pry bar in the shop, a 5-foot steel rod, while Seth took a hammer and a chisel to attack the rusted iron bands holding the crate together. The wood was old but incredibly dense, likely high-grade oak used for heavy transport during the war era. As the first iron band snapped with a loud metallic ping that echoed through the hangar, the pressure on the crate released slightly. They worked in tandem, sweating despite the cool evening air, leveraging the top lid of the crate. With a groan of splintering wood and pulling nails, the first plank came free. Immediately, a new smell hit them, not rot or mildew, but the sharp, chemical, and strangely pleasant scent of cosmoline. This was the heavy, wax-like preservative used by the military to store equipment for long-term survival. It was a good sign. It meant whatever was inside hadn't just been left to rust. It had been prepared for a deep sleep. They stripped away the remaining top planks, revealing a layer of heavy, oil-soaked canvas paper. Seth reached in and sliced the paper with a utility knife, peeling it back. Underneath, the beam of their flashlight caught the reflection of teal-green paint. It was an engine block. But it wasn't a truck engine, and it certainly wasn't a generator. The sheer scale of the valve covers was the first giveaway. They continued to strip the sides of the crate, the wood falling away to reveal the mechanical leviathan in its entirety. It was a V12, but of a magnitude that made a Ferrari engine look like a toy. The cylinder banks were set at a 60-degree angle, massive aluminum castings that gleamed under the layer of protective wax. Caleb wiped a gloved hand across the valve cover, clearing away 70 years of dust to reveal the cast lettering, Packard. They stepped back, looking at each other in total disbelief. This wasn't just an engine. It was a Packard 4M 2500. This was the legendary marine engine that powered the PT boats of World War II, the same type of engine that propelled John F. Kennedy's PT 109. These engines were monsters, supercharged giants capable of producing up to 1,500 horsepower in their standard tune, and significantly more in emergency combat power. Finding one was rare. Finding one still in the original shipping crate, seemingly untouched since 1945, was statistically impossible. The brothers realized that the $5,000 they had spent was a joke. To a collector or a museum, this engine, in this condition, was worth easily 6 figures. They walked around the engine, inspecting the ancillary components. The massive centrifugal supercharger was mounted at the rear, a complex snail shell of aluminum designed to force-feed air into the 12 hungry cylinders. The 4 Holley carburetors were still sealed with red plugs to prevent debris entry. The magnetos, the spark plugs, the intricate linkage of the throttle system, everything was there. It was a time capsule. However, the external condition was only half the story. An engine that sits for 80 years, even in cosmoline, faces internal threats. Moisture could have condensed inside the cylinders, rusting the pistons to the liners. The bearings could be dried out. The valves could be seized. They had bought a museum piece, but their goal wasn't to put it on a shelf. They wanted to hear it run. The brothers began the initial assessment, looking for the data plate. They found it riveted to the side of the crankcase. Bureau of Ships, it read, followed by a serial number and a production date of November 1944. This engine had been built at the height of the Pacific War, crated up for deployment, and then forgotten. It had likely sat in a reserve depot, then moved to a warehouse, then to another, passing through generations of inventory managers who had no idea what was inside the heavy wooden box. Now, it belonged to Caleb and Seth. The excitement of the discovery was quickly replaced by the weight of the challenge ahead. They didn't have a manual. They didn't have spare parts. They didn't even have a stand capable of holding the 3,000-pound beast. They were standing at the foot of a mechanical Everest. The first step was to determine if the engine was seized. If the crankshaft wouldn't turn, the project was dead in the water, requiring a total, invasive rebuild that could take years. Caleb fetched a large breaker bar and found the socket that fit the turning nut on the front of the crankshaft. The room went silent. Seth held the flashlight steady on the timing marks. Caleb applied pressure, gently at first, terrified of breaking a ring or scoring a liner. He leaned his weight into the bar. For a second, nothing happened. The friction of 8 decades held firm. Then, with a thick, syrupy resistance, the bar moved. The internal gears meshed, the pistons slid in their oil-coated bores, and the massive engine turned over. It wasn't free, it was stiff with cold, solidified oil, but it moved. It was alive. The brothers grinned at each other. They weren't just going to clean it, they were going to wake it up. With the engine confirmed to be free-turning, the initial euphoria faded into the harsh reality of the work ahead. The Packard V12 was a masterpiece of 1940s engineering, but it was currently entombed in 80 years of solidified cosmoline. This protective wax, applied thick and hot in 1945, had done its job of preventing rust, but it had now hardened into a substance resembling hardened tar. Before they could even think about ignition, every square inch of the engine had to be stripped clean. If they ran the engine with this coating, the heat would melt the wax, dripping it onto the exhaust manifolds and likely causing a catastrophic fire. The brothers suited up in Tyvek suits and respirators, preparing for a chemical battle. They dragged the massive engine, still on the base of its shipping crate, out onto the concrete apron in front of the hangar. The sunlight hit the dark, waxy surface, making it look like a beast emerging from a swamp. They utilized a high-pressure industrial steam cleaner, blasting the engine with superheated water and solvent. The process was slow and messy. As the steam hit the cold metal, clouds of white vapor engulfed the brothers. Inch by inch, the brown sludge began to slough off, revealing the stunning, preservation-quality teal paint beneath. It took 2 full days of scrubbing with stiff bristle brushes and solvent to clean the intricate cooling fins of the cylinders and the complex linkage of the carburetor banks. When they were finished, the engine looked brand new, a gleaming jewel of aluminum and steel that seemed impossible to have come from a rotting wooden box. The next major hurdle was the mounting system. A marine engine of this magnitude produces immense torque, enough to twist a standard automotive engine stand like a pretzel. If they tried to start this beast without it being bolted to something immovable, it would literally flip itself over, destroying the engine and killing anyone standing nearby. Caleb, the fabrication specialist of the duo, began designing a test stand using heavy-gauge I-beams salvaged from a demolished bridge. He cut the steel with a plasma torch, the sparks cascading to the floor, and welded the frame into a rectangular cradle designed to withstand 5,000 foot-pounds of torque. They drilled mounting holes to match the engine's bedplate pattern, a task requiring a magnetic drill press due to the thickness of the steel. Once the stand was painted and cured, they used the gantry crane to carefully lift the 3,000-pound engine from the pallet. The suspension of the engine in the air was a tense moment. One slipped chain or a failed lifting would result in a disaster. Slowly, Seth guided the behemoth down onto Caleb's custom stand. The bolt holes lined up perfectly. They tightened the massive mounting bolts with a 3-foot torque wrench, securing the engine to its new temporary home. Now, the real mechanical archaeology could begin. They needed to address the support systems. A marine engine is designed to sit in a hull, pulling infinite cooling water from the ocean and pumping oil from a remote tank. On the shop floor, it had none of these things. They had to build a life support system from scratch. The oil system was the most critical. The Packard was a dry sump engine, meaning it didn't hold oil in a pan like a car. It required a large external tank to feed the pressure pump. If they cranked it without a supply of oil, the bearings would be wiped out in seconds. They located a clean 55-gallon steel drum and modified it to serve as the reservoir, welding fittings to the bottom to feed the massive oil lines. The volume of oil required was staggering. They poured in 30 gallons of heavy-duty, straight-weight aviation oil, costing nearly $1,000 just for the lubrication. Connecting the plumbing was a puzzle of finding fittings that matched 1940s naval standards, eventually requiring them to machine custom adapters on the shop's lathe to bridge the gap between World War II threads and modern hydraulic hoses. With the vanes of the engine connected, they turned their attention to the nerves, the ignition system. The Packard utilized a dual magneto system, a redundancy feature for combat aircraft and boats. If one electrical system failed, the other would keep the engine running. Each of the 12 cylinders had 2 spark plugs, meaning they had to check 24 individual firing points. Seth removed the magneto covers, revealing the complex internal breaker points. To their relief, the internals were pristine, protected by the sealed housing. However, the spark plug wires were stiff and brittle. They had to fabricate a custom ignition harness, measuring, cutting, and crimping 24 heavy-gauge wires, routing them neatly through the original looms to maintain the historic aesthetic. The moment of truth for the electrical system involved a test of the starter motor. This wasn't a small 12-volt starter. It was a heavy-duty, 24-volt electric motor geared to turn over high-compression cylinders. They wired up 2 heavy-duty commercial truck batteries in series to create the necessary voltage. Caleb held the remote starter switch, a simple push-button wired into the solenoid. "Clear prop," he joked, a nod to the engine's aviation heritage. He pressed the button. A loud metallic clack echoed through the shop as the solenoid engaged, followed by the high-pitched whine of the starter motor. The massive fan belt pulleys began to rotate. The engine turned over, slowly at first, then picking up a rhythmic, chugging speed. Chug, 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 chug. The sound was heavy and industrial, like a locomotive breathing. They weren't trying to start it yet. The fuel lines were disconnected. They were trying to build oil pressure. They watched the mechanical gauge they had plumbed into the main oil gallery. The needle sat at 0. 10 seconds of cranking. Still 0. 20 seconds. Caleb released the button, the starter winding down. "We have no pressure," he said, wiping sweat from his forehead. Without oil pressure, the engine was a brick. If the internal pump was cavitating or if there was a blockage deep in the oil galleries, they would have to tear the entire engine apart. They cracked open the feed line at the pump inlet. Oil flowed out, proving the tank was feeding the pump. The issue was internal. They decided to prime the system forcefully. Seth rigged up a pressure pot, a device used to force fluid through lines, and connected it directly to the oil pressure sensor port. They were going to force oil into the engine backward, filling the galleries from the top down to push out any airlocks. They pumped until they saw oil weeping from the rocker arms at the very top of the cylinder heads. It was a good sign. They tried cranking again. Chug, chug, chug. The needle on the gauge flickered, then jumped. 10 psi. 20 psi. 40 psi. "We have pressure," Seth shouted over the noise of the starter. The oil system was alive. The engine was lubricating itself. Now, the only thing missing was fire. The fuel system on the Packard consisted of 4 massive Holley carburetors sitting atop the supercharger. These were complex instruments designed to mix air and high-octane fuel at precise ratios. Even though they were plugged, the diaphragms inside were likely dried out. They unbolted the carburetors and took them to the workbench for a rebuild. Inside, they found the only deterioration they had seen so far. The cork floats had turned to dust, and the old fuel residue had turned into a green varnish. It took 3 days of soaking in ultrasonic cleaners and carefully cutting new gaskets by hand to restore the fuel mixers. They reinstalled them, bolting the heavy units back onto the supercharger housing. The setup was complete. They had cooling, a customized radiator rig from a bulldozer connected to the water pump. They had oil pressure, they had spark, and they had fuel. The brothers stood back and looked at the setup. It looked less like a mechanic's bay and more like a mad scientist's laboratory. Wires, hoses, and gauges surrounded the green giant. They filled a 5-gallon jerry can with high-octane racing fuel. Standard pump gas would cause detonation in a high-compression supercharged engine and plumbed it to the fuel pump. It was time. This wasn't just turning it over. This was an attempt at ignition. If the timing was off, the engine could kick back and destroy the starter. If a valve stuck, it could shatter a piston. The risks were incredibly high. Caleb put on his ear protection and nodded to Seth, who stood ready with a fire extinguisher. "Contact," Caleb said, flipping the magneto switches to on. The circuit was live. The sleeping giant was about to wake up. The air in the hangar hung heavy with anticipation, the silence absolute save for the hum of the electric fuel pump priming the float bowls. Caleb's finger tightened on the starter button. He pressed it. The high-torque starter whined, engaging the massive flywheel with a violent metallic clank. The engine began to rotate, the huge pistons pumping up and down in the cylinders, compressing the air and fuel mixture. Whoosh chug, whoosh chug. The sound of the compression alone was intimidating, deep and rhythmic, like a giant clearing its throat. For 10 agonizing seconds, there was nothing but the sound of the starter motor straining against the compression and the mechanical noise of the valve train. The engine was cold, the fuel was traveling through dry manifolds, and the spark needed to find a volatile vapor. Then it happened. Cylinder number 7 fired. A singular, explosive pop echoed like a gunshot inside the metal hangar, followed immediately by a puff of black smoke from the short exhaust stack. The engine stumbled, the rotational speed jumping for a split second before the starter had to take over again. Caleb didn't let off. He knew the beast was waking up, it just needed to clear its throat. He feathered the throttle linkage by hand, opening the butterflies just enough to let the engine breathe. Another cylinder fired, then 2 more in rapid succession. The rhythm changed from a mechanical churning to a jagged, violent staccato. BAP, BAP. Bap. Boom. With a roar that shook the concrete floor beneath their boots, the Packard V12 caught life. The starter disengaged, and the engine surged to a rough idle. The noise was indescribable. Without mufflers, the exhaust from 12 cylinders, each displacing over 200 cubic inches, was a physical assault on the senses. It wasn't just a sound, it was a pressure wave. The brothers could feel the percussion in their chests, a deep, resonant thumping that rattled the tools on the nearby workbenches. Blue and orange flames, visible even in the daylight of the shop, licked out of the short exhaust stacks, snapping and popping as the engine burned off the remaining cosmoline and assembly oil. The shop instantly began to fill with a haze of blue smoke, a mix of burning preservation wax and rich exhaust fumes. Seth, watching the gauges like a hawk, signaled frantically with a thumbs up. Oil pressure was pegging the needle at 80 psi. The temperature was climbing steadily. The alternator was charging. The machine was running under its own power for the first time in nearly 80 years. Caleb carefully adjusted the idle screw, smoothing out the lope. As the engine warmed up, the jagged, angry idle smoothed into a terrifyingly consistent hum, a deep, menacing growl of raw power. The vibration through the I-beam stand was intense but controlled. The engine was balanced perfectly. They stood there for a full minute, mesmerized by the sheer violence of the mechanical energy they had unleashed. The wind from the cooling fan was like a hurricane, blowing debris across the shop floor. Caleb cut the ignition. The engine spun down, the momentum of the heavy internal components keeping it turning for several seconds after the spark was killed, finally coming to a rest with a last, sighing hiss of compression. The silence that rushed back into the hangar was deafening in its own right. The brothers pulled off their ear defenders, their faces covered in a fine mist of oil and soot, grinning like maniacs. The smell of hot metal, unburned hydrocarbons, and curing paint was thick in the air, the perfume of victory. They had successfully resurrected a World War II legend. But the test run revealed something unexpected. As they inspected the engine during the cool-down phase, checking for leaks or stress fractures, Seth noticed something odd about the supercharger drive gear housing. The paint on the housing was slightly discolored, darker than the rest of the teal block, suggesting it had been subjected to extreme heat at some point in its past, or perhaps replaced. He grabbed a rag and wiped away a layer of grime near the casting numbers on the blower. There was a hand-stamped marking that wasn't on the standard data plate, EXP X44. They pulled the reference manuals they had downloaded, scans of original Navy maintenance logs. The standard 4M 2500 engine used a specific gear ratio for the supercharger to provide reliable boost for long patrols. However, the marking EXP usually denoted experimental. Intrigued, Caleb decided to count the rotations. He marked the crankshaft pulley and the supercharger impeller with a paint pen. They hand-turned the engine. For every single rotation of the crank, the supercharger spun significantly faster than the manual specified. This wasn't a standard patrol boat engine. This unit had been hot-rodded by the Navy. It was overdriven to produce significantly more boost, and therefore significantly more horsepower than the stock 1,500 HP rating. This discovery changed the narrative of the crate completely. This wasn't just a spare engine. It was a high-performance variant, likely built for a specific, high-speed interception craft or a classified testing program. The risk of running it increased exponentially. An overdriven supercharger creates immense heat and pressure. The standard bulldozer radiator they had rigged up would be woefully insufficient if they tried to run the engine for more than a few minutes. They needed a cooling system capable of shedding the heat of a small nuclear reactor. Furthermore, running a marine engine with no load, no propeller in the water, was dangerous. The engine revved so freely that a slip of the throttle could send the RPMs past the red line in a fraction of a second, potentially causing the flywheel to explode. To truly test it, and to understand the capabilities of this X-class variant, they needed a way to put a load on the engine. They needed a dynamometer, but industrial dynos capable of handling 2,000 plus horsepower and 4,000 lb-ft of torque were rare and incredibly expensive to rent. They had to improvise. They spent the next week engineering a solution. They sourced a massive hydraulic pump from a scrapped injection molding machine, a piece of industrial equipment designed to move massive amounts of fluid against resistance. By coupling the engine's output shaft to this hydraulic pump and restricting the flow of the fluid through a series of adjustable high-pressure valves, they could create resistance. The energy would be converted into heat in the hydraulic fluid, which was easier to cool than the engine itself. It was a crude, homemade water brake, but it would allow them to open the throttle without blowing the engine up. The fabrication of the adapter plate to connect the Packard's output flange to the hydraulic pump shaft took 3 days of precision machining. Alignment was critical. If the shafts were off by even a fraction of a degree, the vibration would shatter the coupling and send shrapnel flying through the shop. They used dial indicators to align the massive components to within 1/1000th of an inch. They built a safety cage around the coupling using expanded steel mesh, a necessary precaution against catastrophic failure. With the dyno built and the cooling system upgraded with a second radiator and high-flow electric fans, they were ready for the second run. This time, it wasn't just about making noise, it was about gathering data. They wanted to see what the EXP X44 stamp really meant. They hooked up modern digital sensors to the engine, exhaust gas temperature probes, a wideband oxygen sensor, and a digital tachometer, hiding the wires to keep the vintage look but needing the modern data to save the engine. They fired it up again. The start was cleaner this time, the engine settling into a roar immediately. Caleb sat at the control station, monitoring the laptop screen displaying the sensor data. Seth manned the hydraulic valves, ready to apply the load. "Applying load," Seth shouted over the roar. He turned the large iron wheel on the flow restriction valve. The tone of the engine changed instantly. The pitch dropped as the resistance bit, the engine hunkering down against the load. Caleb advanced the throttle to compensate. The V12 growled, the supercharger whine rising to a piercing scream that cut through the exhaust noise. On the screen, the numbers were climbing. Torque, 1,200 lb-ft, 1,500, 1,800. The engine wasn't even sweating. The boost gauge, which on a stock engine would peak at 18 psi, was already climbing past 20. "It's barely working," Caleb yelled. "Give it more." Seth cranked the valve down. The hydraulic lines stiffened under the pressure. The engine roared louder, the exhaust stacks glowing a dull cherry red in the dim light. They were pushing 2,000 lb-ft of torque at only 2,000 revolutions per minute. This engine was a monster. Suddenly, the shop lights flickered. The ground vibration had shifted in frequency. A high-pitched, harmonic resonance began to ring out, distinct from the engine noise. It was coming from the crate wood they had stacked in the corner, the pieces of the original shipping box. The vibration was causing something inside the wood to rattle. It was a distraction, but Caleb's eyes were glued to the boost gauge. It hit 25 psi. This was uncharted territory. The horsepower calculation on the screen flashed past 2,200 HP. They were approaching the theoretical limits of the airframe it was designed for. Then, a warning alarm blared on the laptop. "Exhaust gas temp on cylinder 3 is spiking." Caleb shouted. "Shut it down." He killed the ignition. The room plunged into silence again, save for the hissing of the cooling system and the ticking of cooling metal. They had pushed it hard, but the spike on cylinder 3 was worrying. A lean condition? A sticking valve? Or something else? While waiting for the engine to cool down so they could pull the spark plug on cylinder 3, Seth walked over to the pile of crate wood that had been vibrating. The rattle had been annoying him. He picked up the heavy oak plank that had formed the false bottom of the crate. It felt unusually heavy, even for oak. He looked at the end grain. It looked odd, as if the wood had been split and glued back together. He grabbed a chisel and jammed it into the seam. The wood split open. It wasn't solid oak. The center had been hollowed out. Embedded inside the wood, wrapped in oilcloth, was a flat, metal object. Seth pulled it out. It was a machinist's logbook, bound in leather, and a set of rolled blueprints. He opened the logbook. The first page was stamped, "Top Secret, Project Thunderbolt, 1945. The handwriting was frantic, scribbled in pencil. Unit X-44 exceeds all durability tests. Output sustained at 2,800 HP. Vibration issues at high RPM solved by internal counterbalancing. Warning: do not deploy without reinforced hull mounts." Seth looked at Caleb, his face pale. "Caleb, this isn't just a hot rod engine. This is a prototype for a weapon system that never officially existed." They had the engine, and now they had the manual that explained why it was hidden. But the logbook contained one more entry on the final page, a coordinate and a name, "Test hull scuttled at," followed by a set of latitude and longitude coordinates in a freshwater lake only 4 hours from their shop. The engine wasn't just a piece of history. It was the key to finding the rest of the ghost ship. The discovery of the logbook changed the trajectory of the entire project. Caleb and Seth were no longer just mechanics restoring a vintage engine. They were now investigating a cold case involving classified naval history. The engine cooled in the background, ticking softly as the metal contracted, while the brothers pored over the brittle yellowed pages of the Project Thunderbolt journal. The notes painted a picture of a desperate, late-war initiative to create a super-fast interceptor craft, a hydrofoil design capable of speeds exceeding 60 knots to counter advanced enemy submarines. The engine they had just fired up, Unit X-44, was the starboard powerhouse for this prototype vessel. The logbook's final entry was grim: hull instability at speed. Structural failure imminent. Scuttled to prevent technology capture. Coordinates logged. The coordinates pointed to a remote, deep-water section of Lake Pend-Oreille in Idaho, a location historically used by the U.S. Navy for acoustic testing due to its immense depth and silence. The brothers wasted no time. Leaving the Packard V12 secured in the shop, they loaded their heavy-duty pickup truck with a different set of tools. Side-scan sonar equipment, a high-definition remotely operated vehicle, ROV, with a robotic manipulator arm, and diving gear. The drive to the lake was tense. They were chasing a ghost. If the logbook was accurate, an experimental World War II warship was sitting at the bottom of that lake, and they possessed the only living part of it. The implications were massive. If the hull was still there, it was technically government property, but maritime salvage laws on abandoned wrecks in public waterways were a gray area they were willing to navigate. Their primary goal was confirmation. They needed to see the machine that required a 2,800 horsepower engine. Arriving at the coordinates, the lake was eerily calm, a sheet of dark glass reflecting the gray sky. They launched their small survey boat, a modified aluminum skiff fitted with a winch for the sonar, towfish. Seth manned the helm, keeping the boat on a precise grid pattern over the GPS coordinates derived from the 1945 logbook. Caleb sat in the bow, eyes glued to the laptop screen, watching the waterfall display of the sonar returns. The lake bottom here was nearly 1,000 feet deep, a flat plain of silt and darkness. For 2 hours, they saw nothing but the flat line of the lake bed. Doubt began to creep in. The coordinates could have been deliberately falsified to mislead enemy spies, or the wreck could have slid into an underwater ravine. Then the sonar screamed. A massive hard return appeared on the screen, painting a distinct, bright yellow shape against the dark blue background of the deep water. It wasn't a rock formation. The lines were too straight, the angles too sharp. It was a vessel, approximately 80 feet long, resting upright on the bottom. The shape was wrong for a standard PT boat. It was narrower, sleeker, and appeared to have wing-like structures protruding from the hull, hydrofoils. "Target acquired," Caleb whispered, his heart pounding. They dropped the anchor to hold their position and prepared the ROV. This was the moment of truth. The little yellow robot splashed into the water, its lights cutting into the green murk. As it descended, The water turned from green to black. Caleb piloted the drone from the surface, watching the depth gauge tick down. 200 feet. 500 feet. 800 feet. The pressure down here was crushing. At 950 feet, the bottom came into view, a moonscape of gray silt. And there, looming out of the darkness like a sleeping leviathan, was the stern of the ship. It was unlike anything they had ever seen. The hull was not wood, like the PT boats of the era, but riveted aluminum, a material that was incredibly precious and rare for boat building in 1945. This confirmed the experimental status immediately. Caleb maneuvered the ROV up and over the stern. The propellers were massive, bronze screws designed for high-speed cavitation. He flew the drone forward, towards the engine compartment. The deck hatches had either rotted away or been blown off during the scuttling, leaving the engine bay exposed to the water. He toggled the high-intensity spotlights. Inside the dark cavern of the hull, the camera revealed the truth. On the starboard side, there was a gaping emptiness, a massive steel engine mount bolted to the frame, but completely bare. The mounting bolt pattern was unmistakable. It was the exact match for the Packard engine sitting in their shop. Unit X-44 had been removed before the ship was sunk. But on the port side, the twin engine was still there. It was a twisted, mangled wreck. The cylinder heads were blown apart, the supercharger housing shattered. The logbook's mention of structural failure likely referred to a catastrophic engine explosion that compromised the hull. The brothers were looking at the corpse of Unit X-43. The preservation in the cold, fresh water was haunting. The gauges in the engine room were still readable, the glass unbroken. But it was what lay forward of the engine room that caught Seth's attention. "Go to the bow," he said, pointing at the screen. The logbook mentioned a payload. Caleb thrust the ROV forward, gliding over the sleek, narrow cockpit. The glass canopy was intact, greenish with algae but unbroken. Inside, a skeletonized seat remained, ghostly evidence of the test pilot who had once sat there. Forward of the cockpit, where the gun turret would normally be on a PT boat, there was a smooth, flush deck. There were no guns. Project Thunderbolt wasn't a gunboat, it was a delivery system. In the center of the foredeck sat a square, reinforced hatch, secured with heavy, locking wheel clamps. It looked like a bank vault door set into the deck of a boat. The ROV hovered over the hatch. It was marked with a symbol, a red lightning bolt inside a white triangle, the insignia of the project. The hatch was untouched. Whatever Project Thunderbolt was designed to carry at 60 knots was still sealed inside that compartment. The brothers looked at each other. This was no longer just about an engine. They had found a sealed vault at the bottom of a lake, guarded by a prototype warship. The logbook had hinted at sensitive telemetry equipment, but the size of the hatch suggested something larger, heavier. Caleb used the ROV's manipulator arm to test the hatch wheel. It was fused solid by 70 years of corrosion. They couldn't open it with the drone. To see what was inside, they would need heavy lifting gear to raise the hatch, or perhaps the entire bow section. But then, Caleb noticed something glinting in the sediment near the hatch hinge. He zoomed the camera in. It was a small, brass plaque, riveted to the deck. The engraving was crisp in the high-definition feed. Property of U.S. Treasury, Gold Reserve Transport DIV. The air left the boat. They weren't looking at a weapon delivery system. They were looking at a high-speed transport for high-value assets. The Project Thunderbolt wasn't about fighting. It was about moving national treasure fast enough to outrun interception. The payload wasn't telemetry. It was bullion. The brothers realized the immense scale of what they had found. They had the engine that proved the boat's identity, the logbook that proved its mission, and now the visual confirmation of a sealed treasury compartment. However, the discovery came with immediate danger. On the sonar screen, a new signal appeared. It was small, moving fast, and coming directly towards their position. It wasn't a fish. It was another boat. They looked up to see a dark, unmarked, rigid-hull inflatable boat tearing across the lake towards them, leaving a white wake. The logbook had warned about technology capture. It seemed the site wasn't as forgotten as they thought. Someone else knew about the Thunderbolt, and they were watching the coordinates. Caleb frantically began reeling in the ROV. "Get the winch!" he yelled. The dark boat slowed as it approached, two figures on board watching them through binoculars. They weren't law enforcement, they were private security. The brothers had triggered a silent alarm, perhaps a sensor left on the wreck years ago, or they had simply been watched since they bought the crate. The race was on. They had the evidence, they had the location, and they had the key to the mystery back at the shop, but they had to get off the water before they were intercepted. The engine in the shop was suddenly not just a restoration project. It was the only leverage they had in a game that was rapidly becoming dangerous. As the ROV broke the surface, Caleb hauled it aboard, not bothering to stow it properly. Seth gunned the throttle of their skiff, the outboard motor screaming as they banked hard away from the approaching vessel. The chase was short. The intercepting boat didn't follow them to the marina, likely unwilling to cause a scene in public, but the message was clear. The wreck of the Thunderbolt was claimed. But the brothers had something the other side didn't. They knew that the payload hatch had a secondary locking mechanism detailed in the logbook, a mechanism that required a specific magnetic key, a key that the logbook noted was secured within the crate of Unit X-44. They drove back to the shop in silence, the adrenaline crashing. They rushed to the wooden pieces of the crate they had nearly thrown away. Seth grabbed the false bottom plank where they found the logbook. He smashed the remaining wood against the concrete floor. It splintered apart. Tumbling out of the hidden recess was not a key in the traditional sense, but a heavy, machine cylinder of tungsten and cobalt, a magnetic interface tool. This was the key to the vault at the bottom of the lake. They held the opener to a treasury shipment, but they couldn't go back to the water, not alone. They needed to bring the authorities into this before the private security team scrubbed the site. But first, they had to prove what was inside. They looked at the Packard engine. To prove the claim, they had to prove the engine came from that hull. And the only way to do that was to match the serial numbers on the engine to the broken mount on the wreck, which they had captured in 4K video. The atmosphere in the shop shifted from discovery to defense. Caleb and Seth knew that possessing the magnetic key and the location of a sunken federal asset placed them in a precarious legal and physical position. The private security boat they had encountered on the lake proved that others were hunting for the Thunderbolt, likely rogue salvage operators who knew the legend but lacked the specific coordinates, until now. The brothers decided that the only way to protect themselves and their discovery was to go straight to the top. They spent the night scanning every page of the logbook, backing up the ROV footage to multiple hard drives, and drafting a detailed report. At dawn, they didn't call the police. They contacted the Naval History and Heritage Command and the Department of the Treasury's Recovered Assets Division. The response was swift and overwhelming. Within 24 hours, the dusty gravel lot outside their hangar was filled with black government SUVs. Agents from the Naval Criminal Investigative Service, NCIS, and Treasury officials entered the shop, skeptical at first of the wild claims made by two mechanics. However, the evidence was undeniable. The centerpiece of the room, the gleaming teal-green Packard V12, stood as silent testimony. Caleb handed the lead agent the leather-bound logbook and the heavy tungsten magnetic key. The mood in the room changed instantly when the agent saw the Project Thunderbolt stamp. This wasn't just salvage. This was a piece of classified history that had been missing for 75 years. To seal the deal, Caleb offered to demonstrate the asset. He primed the fuel system and hit the starter. The massive V12 roared to life, the sound deafening in the enclosed space. The agent stepped back, awestruck by the violence and perfection of the running engine. The digital readout on the laptop screen showed the experimental cam profiles and the boost pressure, proving beyond a shadow of a doubt that this was Unit X-44, the missing twin to the wreck at the bottom of the lake. The engine wasn't just a motor. It was the forensic link that tied the location, the key, and the treasure together. The lead agent made a call. The operation was a go. The brothers weren't arrested. They were deputized as civilian consultants for the recovery mission. 3 days later, the scene at Lake Pend O'Reilly was drastically different. The brothers returned not in a small aluminum skiff, but aboard a massive U.S. Navy salvage barge. The area was locked down, with patrol boats keeping the curious, and the rogue salvage hunters miles away. The Navy utilized a deep-sea saturation diving team and a heavy-lift crane to descend to the wreck of the Thunderbolt. Caleb and Seth watched the operation from the command center, seeing their discovery through the high-definition monitors of the Navy's advanced submersibles. The goal wasn't to raise the entire disintegrating aluminum hull, but to surgically recover the reinforced bow vault. The divers used thermal lances to cut the vault free from the rotting deck. The crane winched the heavy steel box to the surface, the water cascading off it as it breached for the first time in decades. It was placed gently on the deck of the barge. The moment of truth had arrived. The Treasury official stepped forward, taking the tungsten magnetic key that Seth had found hidden in the crate. He inserted the cylinder into the recess on the hatch. There was a deep, mechanical thunk as the internal magnets aligned and the locking bolts retracted. The seal was broken. They lifted the heavy steel lid. Inside, nestled in rotting canvas bags that disintegrated at the touch, were rows of dull, gray metal bars. They weren't gold. Caleb felt a moment of confusion, but the Treasury agent's eyes widened. He picked one up. It was incredibly heavy, far denser than steel. He wiped the slime from the stamp, Platinum, Strategic Reserve, 1945. The shipment wasn't currency. It was industrial platinum intended for the catalytic cracking process in high-octane aviation fuel production, a material absolutely critical to the war effort and worth exponentially more than gold by weight in the modern market. The vault contained 400 kilograms of investment-grade platinum. The valuation was staggering. At current market rates, the metal alone was worth over $12 million. But the value went beyond the raw material. The historical significance of the find, the prototype boat, the experimental engine, and the recovered reserve made it a priceless time capsule. The government took possession of the platinum, but the brothers' legal position was solid. Under federal salvage laws and the specific treasure trove provisions for recovering lost state assets, they were entitled to a substantial finder's reward, calculated as a percentage of the recovered value. Furthermore, their cooperation and the preservation of the key evidence, the engine, earned them significant goodwill. The final settlement took months of legal wrangling, but the result was life-changing. The brothers were awarded a $2.4 million finder's fee for the recovery of the platinum. In addition, the National Museum of the United States Navy purchased the Packard X-44 engine from them for a separate sum of $350,000, intending to display it as the only surviving example of the Thunderbolt program. The engine they had bought for $5,000 as a scrap gamble had generated nearly $3 million in profit. Caleb and Seth didn't retire to a tropical island. They were mechanics at heart. They used the money to buy the hangar they had been renting, completely renovating it into a world-class restoration facility. They upgraded their tools, bought a heavy-duty dyno room, and hired a small team of fabricators. They dedicated a permanent display in the lobby to the Thunderbolt adventure, featuring the original wooden crate panels, the logbook, which they were allowed to scan, and a replica of the magnetic key. The real Packard V12 was shipped to the museum, but not before they recorded one final, high-fidelity video of it running at full power, a video that hit 10 million views on their channel within a week. The gamble on the mystery box had paid off in ways they never imagined. It validated their instinct that history is often hidden in plain sight, waiting for someone with the courage to pry open the lid. As they closed the heavy steel doors of their new shop that night, looking at the rows of new projects waiting for their attention, they knew this was just the beginning. The world was full of forgotten barns, locked containers, and sunken secrets. And now, they had the bankroll to hunt them all. Thanks for watching this incredible journey. If you enjoyed the ride, Don't forget to like and subscribe. We've got another auction coming up next week, and the listing just says, Sealed Bunker. You won't want to miss it.